Very good morning, friends. In today's video, we are going to work out a problem wherein a steel shaft of 50 millimeter dia is welded to a vertical column, that is a steel column, by fillets all around the diameter. And we need to find out what should be the size of the weld required to sustain a torque of 40 kilonewton meter, and in the second case 40 kilonewton meter of bending moment. See friends, if you refer to the machine design data handbook on this chapter, welded joints, you will have lot of equations for various types of problems. For example, like a circular rod which is welded around its periphery, and a square rod, a rectangular rod, I section, etc. And in today's video, as per the problem, there is a shaft of diameter 50 mm, and this is welded to a vertical column, is a steel column, by means of a fillet weld. And they have given us what is the shear stress induced because of this torque MT, and this MT value is given to be 40 kilonewton meter, 40 kilonewton meter. And if you refer to the data handbook, for a case wherein the shaft is subjected to a torque or twisting moment of 40 kilonewton meter, we have the formula given as the shear stress induced is given by the formula 2.83 MT divided by h d square phi. This is available in the machine design data handbook, wherein lot of such cases of the members welded to vertical column are given. Friends, here let us see what are the parameters. Tau is the shear stress, and that value is given to be 75.8 Newton per mm square. Friends, remember, in most of the cases, the value of the shear stress is not given, and there is a table in the machine design data handbook on the welded joints which will give the value of the shear stress and the value of the bending stress and the value of the tensile stress. All these are given in the same table, and you have to refer to the table and obtain the value in case it is not given. Friend, you have this MT. The value of MT is 40 kilonewton meter. 40 into 10 to the power of 3 is Newton millimeter into 10 to the power of 3 is so many kilo Newton millimeter. And we have this H. H is the size of weld that is to be found out. Size of weld that is to be found out. And D is the diameter of shaft, which is given as 50 millimeter. 50 millimeter. Friends, if you substitute these values, you know this value of tau, H can be found out. So we will substitute all these values and find out the size of the weld required for the case of the torsion. That is 75.8 is the value of this tau. 2.83 multiplied by MT is 40 kilonewton meter. 40 into 10 to the power of 3 into 10 to the power of 3. To convert this to Newton millimeter, divided by H is to be found out. Diameter square is 50 mm square, and the value of pi is known as 3.14. Friends, if you simplify, you will get H, the size of weld, as 19.9 not 2 millimeter. So this is the weld size required to sustain a torque of 40 kilonewton meter by a shaft having diameter equal to 50 millimeter. And this is the answer for the first part of the question. That is, what is the size required? Uh, a torque of 40 kilonewton meter, and the value we have utilized here. Friends, in case number 2, we have a similar problem wherein the shaft size is the same, and instead of this torque there is a bending moment of 40 kilonewton meter. So I will just remove this and utilize the same diagram to solve the second part of the question, in which, friends, this is subjected to a bending moment MB, that is, or along the line it is just twisted like this. That MV value is also 40, sorry, this is 40 kilonewton meter. Friends, if you refer to the same welded joints chapter, for this MB case, we have the bending stress induced in the member as 5.66 MB, sorry, divided by HB square pi. This is the equation for the case of bending, and this is available in the machine design data handbook. Friends, the value of sigma B is given as 125. If not given, you will have to refer to the data handbook, obtain the value. The same value is available in the data handbook. And friends, here we will substitute the values. Sigma B is 125, 5.66 a constant. MB value is 40 kilonewton meter, 40 into 10 to the power of 3 Newton. Then meter is converted into millimeter, divided by H to be found out. D square is 50 mm square multiplied by pi. Friends, if you simplify, you will get the value of this H, the size of the weld required in this case, as 23.07 millimeter. So friends, if you are very familiar with the use of data handbook, you will be able to solve lot of such problems, and you find a very big table wherein all such different cases of welding done on different shapes of the member are given, and you can practice. Friends, I hope the presentation was interesting, and you please go through the complete video, and if you like my video, do share with all your friends without fail. And in case you have not subscribed to my channel as on date, please do it today itself without fail. Thank you for watching my YouTube video, and have a blessed day.